Okay, tic tac toe tak bana diya, right? हाँ, तो okay, more or less like you'll understand everything जो आज चलेगा types. Right, am I on the right class? This is 1577651 124. 57765111124. Okay. Hey guys, thanks for joining in today. We'll just wait for a couple of more minutes so we have everyone else as well. We'll just give a couple of more minutes to get started, right? हाँ, ये बिठा देना। So you have 5-6 people already. So do people already have exposure to game development, made any games, know anything about it, etc., etc.? Anyone who's already joined, just to get a sense of, if people have some past game development experience, or if you're like completely new, etc. Just let me know in the chat. Accordingly, we can make sure that when you're covering certain topics, you guys are all following along. So today, I think, okay, so there are audience, like there are members in the audience that are completely new to it. I'm guessing like, first year, second year students who are just exploring this new sort of world. If you guys haven't had a chance to check out the session that I did on last weekend, that's available on our YouTube itself. So please reach out after this class and we'll share the link for the YouTube video from last week as well. And mainly it covered general things around what game developers do in the industry, and a lot of non-technical aspects of game development basically. So how professionals work, what kind of teams are structured, like what's the responsibility of a game designer versus a game developer versus a game artist in the industry. So a lot of more sort of broad topics and discussions around game development as an industry. So we covered a lot of these sort of non-technical details, and today we're going to start with our more technical focus and start looking into Unity as a game engine, as well as C# as a programming language. So hopefully most of you are comfortable with at least one programming language, such as Java, C#, C++, something that has OOPS, object-oriented programming, because that is what we'll be using as well. In case you're not, we can share you some links after the class, and you can do a sort of a quick revision of the basic OOPS functionality that will get heavily used, and that will make you comfortable. But anything that's related to Unity and C#, that we'll specifically cover, so that's not something you need to worry about. If you know these basic fundamentals like inheritance and abstraction, and what is a class versus what is a structure, typically the things that you learn in your first programming language, high level programming language. So as long as you have those things covered, then that should be good. Rest everything will pick up. Okay. And if somebody needs a refresher on those things and maybe finds today's class a little bit too difficult, especially when it comes to the C# coding things, just reach out to us after the class, and we'll share some online learning resources with you, everyone. So that way you can just practice a little bit of it and get comfortable with the OOPS fundamentals. Arco says that I have a little bit of experience and I'm quite good in modeling assets. Okay, great. So yeah, modeling is something on the 3D side of things. Specifically, I've been in the industry for more than 10 years now, so I don't know anything about modeling. Well, I know about modeling, I don't do it myself, because my core responsibilities have always been on the programming side of things, designing side of things as well, and more towards project management and mentoring other engineers, etc. Cool. So let me see. There are 8 to 9 people. So all right, we'll get started. Others can join in as they come. So I'll start sharing my screen. Second. All right. There you go. Cool. All right. So hopefully you guys can all see my screen right now. So in our previous session, we covered basics of all the tools that we internally use for all our projects that we'll build, all the things that we use. So going forward, whoever sort of continues with us for the full duration of the course, will get you all set up with everything that you might need, be it the Unity setup, the Visual Studio that we use, etc. All those things will get you set up. That's not an issue. Okay, so right now what you see on my screen, that's basically the Unity hub. Okay, so this is something also we covered in the previous session. This is where you can control what all versions of Unity that you can basically install on your machine. So if I go to this install section, you can see I have like these 5 different Unity versions that I have installed. I might be using one with certain project, I might be using another Unity version with another project, etc., etc. So it purely depends on what kind of projects I'm working on. If I'm working with some company and they have like an old project from 2 years back, you'll see these older versions of Unity. 5.6 is like the older version, 2018 is like later, newer versions. Now there is 2019 versions as well, but I'm not using those for any projects or anything like that. So I don't have it installed yet. But if you want, you can obviously add, and you can select which version of Unity you want to install. So I can select the latest version. As you can see, 2019.2.2 is the latest one. I can just install this from here. And once it's done, it will let me know. Okay. So for now, you can use any version along for this particular project. You can use anything that's 2018 and above, and it should be fine. Cool. So switching to back to the project view, but what we'll do is we'll first get you started with what Unity is, how it works, etc., etc. Okay. I'm pretty sure anybody who's even remotely interested in game development, you would have heard the name Unity 3D somewhere or the other, right? So essentially, it's a game engine, and that's the core game engine that a lot of the companies nowadays use, and a lot of companies are hiring engineers who know, or who know how to work with this game engine. So once you have the Unity engine installed, it will come with Visual Studio as well by default. So you can just do a tick while installing Unity, and it will install Visual Studio for you. So once you have these two sort of softwares installed, we'll come to this project window and we'll say new. And all we are doing is we are creating a new project. Okay. So I'm going to say, I'm going to start a 2D project. Okay. I'm going to say intro to game dev as my project name. And I'm going to choose a slightly different location. I'm going to create a new folder, intro game dev. All right. Cool. So I'm going to select this folder and I'm going to create. So now while this loads up this project, now you'll see what exactly Unity looks like. If this is like your first time, don't worry. We'll just cover the basics of what individual elements of the engine are and how you can, what you can do with it. So give it one time. It's trying to get everything set up. So based on whether if you are starting a new 3D project, so instead of the 2D option, you will select the 3D option. If you're selecting anything that's like the you're making an AR app kind of a thing or a VR application. So you'll accordingly, from the opening window where we were selecting a new project, you can select what kind of a project. In this case, we are going to go with the simplest possible one, which is 2D. So we'll start working with that. All right, cool. So typically now this is how my project looks. Right now it's empty, there's nothing in there, and we'll just quickly look into what each of these pieces that you see on the screen right now mean, okay? So essentially what you see here on the left, this is my scene view. What this does is if I create anything visual, right? Like if you've worked with anything, say something more around Photoshop or any of these visual editing tools kind of thing, right? So whatever is your entire project or entire thing that you see in the game that's set up, so that will show up here, which is basically the scene view, what we call as scene view for Unity. Okay, it just means that this is the current thing that will show up in the game. Okay, and you can like move it around, tweak it, and you'll see how you can change it, etc., etc. While you're building this game, right? So it's like when you talk about theater, right? Like you have a stage. So this is like the stage for your entire game. Okay, so essentially that's your scene view. For those that are a bit late. Okay, got it. Thanks, Vishal. So then you have this thing called as a game view. Okay, so this is essentially what will show up on the screen to the player. So if you're building, say, an Android game, right? So what will show up on the device on your phone when you actually launch the game is basically your game view. Okay, so it's like looking through the camera of the game, and what the camera sees is what you will see in the game view, right? So this view is called the inspector. So it kind of details out each properties of each object that are currently in the game, and we'll just look into what exactly each project like object is and what these properties are. But this is supposed to give you a view into what these properties are for a particular object, where it is, at what degrees it is rotated, things like that, right? This on the right bottom corner that you see is called the project view. This is where you can see all the folders inside your particular thing. So, typically what you see inside your Windows Explorer kind of thing, right? Like this is your entire hierarchy. So you can go create a new folder. I'm going to call it scripts. So I'm going to start putting all the scripts that I create in here. If it's like a 3D project, I'm going to create maybe a folder called models. I'm going to put everything, all the 3D models inside, this particular thing. If I have a lot of images, I might create something like images or textures, I might call them. So they can go by different names, and I'll create a separate folder for that. Okay. So this is basically how you organize your entire project. We'll come to what these scenes are, so don't worry about that. But this project view is essentially your window into your entire file hierarchy and your folder structure for that particular project. Okay, and the scene that you see here, which is the default thing, we didn't create anything. This Unity created for us. Okay, so the sample scene is basically this default stage that Unity creates when you start a new project. We can delete it, we can start a different one, but basically each scene is like a setup. So imagine if you're building like a racing game, right? And you have multiple tracks. Each track can be represented and saved as a separate scene. Okay, So the whole idea is that you break your game into these different scenes that you need at different times, right? So if you have a stage of theater, one stage reflects, say, Melbourne, Australia, another one reflects India, another one reflects London, whatever, right? So each of them are like physical worlds that will exist in your game, but are separate from each other. So we break them into different things called scenes, and each scene is stored as like a single file. So I can double click and open this scene. Right now, the scene is empty. It doesn't have anything, so I don't see it. But imagine if this was like a full racetrack, I would see that racetrack. If I open another scene for another racetrack, I'll see that. And then I can make changes to it and I can save it. So essentially, everything we build in Unity will be stored as a scene. Scene is basically the highest level thing that puts all the objects, cars, models, whatever you have, right? Packs them together into one file and stores it. So what you see in this hierarchy view is basically your current scene that's open. So right now our sample scene is open. So as you can see, there's only one object, which is the main camera, is the only object in this particular scene. So we'll create more objects as we go on today, but this is where in the hierarchy view is where you can actually see what all objects exist. Okay, cool. Now, the thing that you see at the bottom, this thing called console, is the most important tool that you will have access to, because this is where all the information that you want to debug in your game will show up as messages here, right? So if you've worked with any other development environment, say like Android or JavaScript or anything of that nature, you would be familiar with something like console.log, right? Or debug.log kind of things. So Android has something called as ADB that shows you log messages. JavaScript, in JavaScript, you can do console and .log, and it will show a message to, in your browser window, right? So console is exactly the same thing. It lets you display certain messages with information that let you kind of debug your game and figure out what's happening in the game at different stages. Now, when you start your own Unity project, it might not look like this. The reason for that is something called as layout. So I have this custom layout and I have stored this as a layout. So whenever I start a new project, this is the default layout that looks to me. So you can drag these all these windows are sort of, you can move them around, you can drag them. So I've moved the inspector here. So depending on what you're comfortable with, you can, reassign these in parallel. So now I only see this, I can switch them around. So you can do a lot of these things. Each of the window that you see is basically customizable. I want to see my scene view and game view together, so I'm gonna do something like this. Now the blue section that you see is my game view, which basically shows me how it will look on the device. On the left is my scene view, which shows me how I'm setting these up. I can move this around. I can, edit these things, etc., etc. So every sort of window here is customizable. So the setup that you see is how I prefer it. Once you sort of start getting used to it, you'll figure out what you are comfortable with, and you can accordingly move things around and get a hang of how you like to, create this view for you. And then you can go to layout and say save layout. But once you have organized these things, you can just save it, and Unity will remember that, hey, this is my custom layout, right? And next time, all you want to do is switch to the default view. So this is the view that normally Unity comes with, which is the default view. I don't personally prefer it, just a matter of taste. So I just switch to custom view. And this is the view that I like to use personally. I find myself more comfortable using this, okay? So it's up to you. You go ahead, play around with it, see what you're comfortable with, and then you can go ahead and save that layout so that next time you don't have to move these windows every time around, and Unity remembers that this is the view that you want to use. All right, cool. So far that's a little bit about these different windows. If accidentally you end up closing any of them, they are accessible through this window option. So all these are available under these different settings. So mine is a Mac. So some of my options might look a little bit different, but you can go and check around in all of these and you will be able to find your specific ones. Let me show you where. So Windows layout. So you see these layout options, and then you have one sec. Yeah, it just keeps moving things around all the time. I think I have all of them open as well. But yeah, you can basically just like don't worry in case you're using a Windows machine and some of the options look different. That's just because I'm on a Mac. Okay, cool. So now this is how an empty project kind of looks like. So to get started, I'm gonna refer to Trello. Now, Trello is the basic project management tool that we use. Again, something that a basic hierarchy overview of it I covered in my previous lecture. So just refer to that YouTube video. We'll share you the link, or just reach out to us after this, and we can share you the link for it. But this will basically going forward for everyone that's enrolled in our program, right? This is how we will cover specific topics each class, and then there will be a follow-up assignment for that particular class that that will give you practice about how to go about actually implementing the things that we have covered. Okay, so we'll kick off by we just kicked off by doing a quick introduction to Unity and the basic views that it covers. Next, we'll cover what is exactly a game object, right? So switching back to Unity. So in Unity's world, everything is essentially a game object. So when I say what that means is that if I want a character to be displayed on a screen, it will be a game object. Anything that's should be visible in the world is a game object. Now, game object is a very generic sort of a thing. Both, if I want to show a 2D image on the screen, that is also a game object. If I want to show a 3D car, that is also a game object. Chances are 3D objects might be a complex combination of multiple game objects. So like the wheel might be one object. You might have four wheels, which are one object, one game object each. Then you have one game object representing the body, and these five objects together form the car, right? Just giving you an example. So typically how objects are structured, they can be simple objects, they can be complex objects. It purely depends on what exactly you're working with. Okay, so ultimately the whole point is that anything that needs to be represented in the engine, and needs to be say shown on the screen, it needs to have a corresponding game object for it. So everything in Unity's world is a game object. Typically, each object lives basically inside the scene. So we just talked about what a scene is, right? A scene is now, the formal definition of a scene is that it's a collection of game objects. So everything put together can be saved as a scene. So now I have this sample scene open. I'm going to right click in my in my hierarchy, and you can see a lot of these options. Create an empty. So this will create me an empty game object that has nothing on it yet. I can go ahead and add it. But Unity also gives us these some sort of standard things that I want. So if I want to create a text on the UI, like show a high score or something like that, or maybe create a play button, anything of that nature, right? It gives me these shortcuts. So it will create an object, it will attach a button and all the other things that it needs to attach. So it will be sort of like a complex game object. Okay. So for now, let's go with creating an empty. So when I created an empty game object, you see this new thing. Earlier we just had the camera. Now it has created this empty. It has created this empty game object, but it still has this. Now when I actually select this object, you can actually see in the inspector view, we can see its properties. So by default, each game object comes with something called as a transform. Okay. So now what is this transform? Transform is something that's internally defined as a standard thing in Unity. What it's supposed to do is supposed to store three things: each object's position, its rotation, and its scale. That's the core idea of a transform. Okay, so and you can see all these three properties here. So this is the position, this is the rotation, and this is the scale. Now this object, if I double click, you can see these arrows inside my scene view, right? This object right now doesn't have anything. That's why I don't see anything in this particular thing. So what I'm doing is I'm using my mouse wheel to zoom in and out so I can get closer, but there's nothing in it because it's an empty object. You see, it doesn't have, like, you don't see a box or anything next to it, right? Because it's an empty object. So, but these arrow indicate its position in the entire world. So where you see these two axes cross, that's the position of this. Uh, that's the position of this game object. In the scene view, you have this sort of 2D button. If you enable it, then we are basically restricting our view, our scene view, to be just 2D. So we're creating a 2D game. We're just restricting the entire thing to be flat, and it will give us a 2D perspective. But I can disable this, and now I see the entire world as a 3D world. So I can move around using my mouse. So all I'm doing right now is right clicking and moving, so I can see the things differently, and I can use zoom in, zoom out to focus on that specific object. So right now I'm clicking on the game object, right? So you see these arrows are positioned here. When I click on the main camera, you'll see the arrows shift, right? Because my camera is positioned there, where you see this sort of white dot thing, right? So this is the position of my camera. You see the Z value, the Z axis is highlighted as -10, versus for my game object, it's highlighted as 0, right? So there is a distance of 10 on the Z axis, which is this blue axis. So the Z axis is blue, and the matching arrow next to it is blue. So when I click and drag this game object around, you can see its corresponding Z value here changes, right? So if I'm moving it closer to the camera, now it's basically at sort of -10, right? If I just move it something like this, I say -10, I can actually type the value, and the position of it updates. So now the game object, the empty game object, and the camera are at the same position, right? You don't see them move around, but you can drag these things, click and drag them, and you can actually move them around, right? I can move them on all the three axes. But for now, we are focusing on doing something 2D. So let's switch back to 2D, and we'll come back to this. Hey, so somebody is trying to scribble on the screen. Can you guys just make sure, one sec, where you can, yeah, one sec. All right, cool. So yeah, so let's go back. So now you can see, since we moved this object around, I now want to bring it back to the center. So you can position these things around if you want exact control. The values of the position. So for me, I want to position them at 0, 0, 0, which is the center of the entire world. The entire 3D/2D world is centered at coordinate 0, 0, 0. I'm just going to change the values quickly here, right? So that's the basic idea about a game object, what exactly a game object is. And now we'll look into some of the other pieces. So we just covered what transforms are. Basically, they're storing all the position data, the rotation data, and the scale. Scale is basically how big. By default, everything comes with a scale of 1, 1, 1. But if I want my something to be stretched along the x-axis, I can make it scale to 2, 1, 1. So that means on the x it's twice as big versus 1, and you can create like some kind of weird looking objects with it. But sometimes it's helpful if you want to quickly scale up something to double its size. You'll simply say 2, 2, and now in the x and the y, if you're making a 2D game, it will become double its size. Okay, so a transform stores rotation, position, and scale. Right. So essentially, everything that you see in Unity, that, if I look at main camera, we just looked at transform. When we created an empty object, we saw this transform component. When, like, you see these individual pieces, transform, camera, audio layer, each of these is called a component. Okay, so the idea is that Unity is heavily dependent on something called as a component architecture. So game object is a generic thing. Rest everything is designed as a component. So like an image is a component. Transform that we just talked about, it's a component. I can attach. Now transform is a special type of a component that cannot be removed from a game object. But camera is just like image or any other components that we'll see, but the idea is that any of these components can be attached or removed from a game object when they're needed. Okay, so I can go on camera, right click on this options menu and say remove component. You see this option, right? So you can say remove. Now, even though this object's name is main camera, it's no longer acting as a camera because I removed the camera component from it. I can go to my other game object and say add component and search for camera. Now my game object suddenly became the camera because it has the camera component on it. So whichever object has camera on it becomes the camera, right? So you can do a lot more things with this, but the core fundamental principle here is that we've taken this empty object, attached a component on it that we wanted, and now that is serving a very different purpose. Earlier, it was an empty object. We could have attached an image on it and it would have turned into an image object. Now we attached a camera component to it, so it has become a camera object. And we can have multiple types of components as well. These are all when you click on this add component option, right, you'll see there are so many different components that Unity provides. So imagine I'm doing something with UI, right? So you see all of these are nothing but components, or some of them could be a group of components. So if I quickly show you, I'm going to create a empty game object. Now in this comp, by default, it comes with obviously the transform component. I'm going to say I'm going to add a UI and I'm going to select a button. Now you'll see Unity add this particular component on it, button. It has a lot of things, which are the different options, etc. And we'll just go into the details of it, but it has created this. I'm going to create another empty game object. This time I'm going to add, let's see, something else. What do I want to add? So I want to add UI. I want to add, say, drop down. So now it has added this drop down component, right? So don't worry about what these components are. We'll just talk about it. So what I want to show you here is that each of these components can be added and removed like on a game object that we want, right? So it's not something that an object named main camera is the one that's supposed to have the camera. I can even delete this particular game object, but I still have a camera by the name of game object in it, and I can rename this to be camera. So it's a very flexible system. I can do any kind of processing on it. I can attach components, I can remove components, and accordingly, that's how my game will will build different games. Okay, so hopefully you guys are following around what these components are. Transform is a special type of a component. Every time you create a new game object, it by default comes with a transform. Okay, cool. So let's quickly, and again, all the scripts that we'll create, right? These are also components. Just that these are not Unity defined components. These are our components. These are the ones that we are creating. Okay. So now we'll quickly jump into a little bit of code and start seeing how we can start coding few basic things in C# and get a hang of it. Okay. So remember, I created a scripts folder. I'm gonna create, right click, create, And here you can see there's an option for C# script. So I'm going to click on C# script. I'm going to give it a name as my first script. Okay, so I'm going to double click. It will open up Visual Studio. So one quick thing is that Unity by default comes with MonoDevelop as the code editor, but we prefer using Visual Studio. It's just much more flexible, powerful to use and build games. So I would recommend if you use Visual Studio instead of MonoDevelop, which is the one that by default Unity comes with. Okay, so for my case, I don't have MonoDevelop. I uninstalled it, so by default it opens up Visual Studio. All right, so we're going to quickly look at what is this sort of. We haven't done any code. We just said create a new C# script, and Unity gave us some of these sort of basic things that are already kind of set up. So some of you might be familiar with classes if you've done any kind of Java, C++, any of these high-level object-oriented programming languages. So again, this is a standard class that we created. We gave it a name, so Unity knows that we want to call this class as my first script, and then it does something that you might not be familiar with. So what is this mono behavior? So what we are doing is that we are inheriting the class we want to create from something called as a mono behavior, which is another class. Okay, so if we just quickly right click, you can go to declaration, and it will open up the actual sort of code for that particular class, not the full code, but more like a definition of that code. Okay, so you can see, okay, this looks scary, right? There's a lot of stuff here. So let's not look at it and don't worry about it, right? But what I wanted to show here is that even though Unity makes it look very easy, we just created a class and we inherited from a mono behavior, which is a Unity provided class, which gives us a lot of this functionality. There's actually a lot of complex logic behind it, and this is just the header file. If you're familiar with C++.h files, this kind of like the header file, and this just the header file, right? So you can imagine how big the actual code for this particular class might be, right? And that's not it, because if you look deeper, this class is inheriting from something called as a behavior class. So you can actually go into that class, and that class is inheriting from a component class, and that class is inheriting from an object class. So as you can see, you are creating a class that has 5 classes above it. There's object class, there's component class, there's mono behavior class, and all that, right? So it's a very big hierarchy of classes, and you're creating your class under it so that you get access to a lot of powerful things that you can do very fast. And we'll look into what these powerful things are. Okay. So by default, the mono behavior class that Unity provides, as you can see in this tooltip that shows up, it's inside the Unity engine namespace. So whenever you're using a Visual Studio kind of an IDE and you start typing mono behavior, if you don't have this using statement for importing the namespace, it will show that, hey, this class, it's not able to figure out where it is. But if you're using some IDE, most likely it will give you this suggestion of where it thinks this class is, and you can just right click here and it will import it for you. Just in case somebody deleted or something, that's how you typically figure out that you don't have to ideally remember, but you should know that where this class exists. Okay. So any component that we create, so my first script is a custom script that we're creating. It's inheriting from a mono behavior, and whenever something inherits from a mono behavior, it becomes a component in the Unity world. Okay, and now I can attach this thing, the script, to any of the game objects through that same add component option, right? So now I just created something and it inherits from mono behavior. Because mono behavior has this complex hierarchy of classes, it gives me this functionality that I can say create an empty object. And now if I say add component, and if I go to the scripts option, you'll see my first script show up here, right? And I can attach this my first script, and now my first script is is something like when we were adding a camera, a button, or something. Now I can add and remove these from these game objects as well. Okay, so if I remove this mono behavior from it, I will not be able to attach them, because then I'm saying that this is a generic. So in case if this was something like this, right? I was not inheriting it from a mono behavior. Now, if I switch back to Unity, it will throw me an error, basically. So you see, it's missing some attribute exception. So it's giving this weird error. And now here the name is also gone, right? Like earlier it was showing my script name, because now this doesn't work. So if I try to add component, I go down to scripts, it will say invalid operation, because it is not in, it needs to derive from mono behavior, okay? So anytime you want to attach something to a game object, you basically need to make sure that it inherits from a mono behavior, right? So let me uncomment this out. Okay, so mono behavior acts as a component for the object in the scene. Yeah, that's correct. So as you can see, if you look at the hierarchy of the classes that we were seeing, right? So if I say go to declaration, you'll see up here, mono behavior inherits from a class called behavior. This behavior inherits from a class called component. So this is that component that we have been talking about so much. Everything in Unity is basically that is attachable to a game object inherit from this class component. Okay, so even the transform class would inherit from this particular thing called component. Right? Cool. So that's the basics of how to create a simple script that you can attach to something. Now, what are all the things that we can do inside the script? Okay. So by default, Unity comes with a bunch of predefined functions. So let me quick. So we just looked at C# scripts. We just looked at mono behaviors. So we'll cover this game loop in a bit. Let me move this down a little bit. So we'll talk about the Unity inbuilt functions that we can take advantage of when we create something as a mono behavior. So as we just created this class, we didn't type in any of our custom code yet, right? But it came with these two sort of predefined functions. One is start and one is update. So what is this all about? Okay, so Unity is like, it gives you even a basic comment about what these functions are. So with start, it told us that this is called before the first frame update. Okay, now what does that mean? So whenever I So I'm going to quickly do something here. I'm going to write a debug log. So just go with me for now. Okay, I'll explain in a second um, what this means, and I'll just first demo it so it's clear in your mind. So I'm adding a debug log message. So we saw the console window, right? So when Unity executes this line of code, it will put this string, whatever I'm specifying, in this case, my first script start function, as a log message in my console. Okay. So this will show up in that console, and it will know, I'll know that, oh, Unity executed this line of code, this line number 10. Okay. And I'm going to put the same message. I'm just copy pasting it and pasting it here, right? But here I'm going to change the message slightly, and I'm going to say update function, right? Because I'm putting it inside the update function, and we'll just see what this is, right? So Unity tells us that update is called once per frame, but we'll now look at in action what's happening. So I switch back to Unity. Unity will first compile the code, make sure nothing is broken or anything like that. That code can compile. After that, I'm going to come here. I'm going to attach add component. Now, every time I don't need to go down scripts and find my script. What I can do is, if you remember what the name of your script is, you can actually start typing it and it will filter it for you. So this is like the shorter way to find the right thing. Now my script is attached, and you can see this my first script name show up as well, right? So now when I want to run my game, you see this play button at the top. All you need to do is hit play. All right. So now Unity will start playing, and here, if you look at the console at the bottom, right, it gave this message, my first start function, right? And you can see on the right side that it happened once. But when you look at this other one, my first script update function, you see its number is keeps going up. So it's happening multiple times. I can actually disable this collapse, and now you'll see the screen keeps scrolling because I keep getting these functions again and again getting called, right? So we'll just look at what this means. So right now my game is running because I hit play. I'm going to pause it. So use the second button to pause the game for now. And if you see here, you see all these different messages. These are from, every of these messages is from the update function. Okay. So all of them are from update function. And the very first one is from the start function, right? So my first start, the collapse button in the console, just since this is a duplicate message, collapse button just lets me compress all of them together, and on the right it shows me how many times it has occurred. So it just cleans it up so I don't have to scroll too much top down. Just a handy way to merge all the duplicate messages together. So here you can see start got called once, but the update got called some 2,300 times or something, right? So what's happening here? The moment I press play, Unity sees that I have this game object on which I have this my first script attached, right? The component attached. So the start function is a predefined function that Unity has given us. It's not our custom function. We didn't call the start anywhere, right? Then how did my, typically when I define a function in any programming language, I have to call that function, right? So if you've written some C++ code, you know about the main function, right? Main function is the default function that gets called, right? Every time you run the program, you're not calling main function, somebody else is, the compiler is. In this case, Unity takes the care of calling this start function. It calls this function the very first time a game object is, it comes into existence, it gets created. In this case, whenever we hit play, my game starts running, Unity loads the default scene, and it sees it has one game object on which my first script exists. So it goes in and checks my first script, does it have a start function? It says, oh yeah, it does, right? And then it starts executing this. It executes it only once, and then after that its job is done. Okay, so that's why we saw the debug log only once. But this update function is very similar to the start function, but it happens once every frame. So if imagine your game is running at 30 frames per second or 60 frames per second, then this function is getting called 30 times or 60 times per second. Each second, this is happening again and again and again and again. Okay, that's why you see when we left the game running for 5-10 seconds, the counter for this particular message went to 2,000 some, right? So these are the internal defined functions that come with Unity. Now there's these internal functions, there's a big list of them. You don't need to know all of them, or you don't need to remember all of them, memorize all of them, but the certain key ones are awake. This is another function. Start, update. There's another function called late update. So these are probably the 4 functions that you'll use the most often. Awake is called even before start. So whenever your scene gets loaded, it's very much like start. It gets called only once, but it gets called even before start. So if I have, I'll just show you. So if I make this change to say awake, right, and I go back to Unity, I just stop the game, and then so right now what I've done is when I uncheck this button, right, I've disabled this object. This lets me enable it, this lets me disable it. So right now my object is disabled. I hit play, you'll see the awake function get called once, and that's it. No start, no update. Why? Because the object has been created, but it is not active. It's disabled. Okay. So awake gets called whenever the object gets created. An object is already created when the game starts. But when I click this button again, that's the time the object will get enabled, and you'll see the start and update functions log message appear. So I click yes, and now you see start getting called once, and update whose increment counter you keep seeing incremented because it's calling it every time. Now when I stop it, you'll see the update counter stop as well. So it stopped, right? Because now this particular component, even though this game object is active, right? You see the tick mark next to the game object. That means the object is active, but individual components are disabled, right? That's why Unity is not calling functions on this component anymore. Our own defined scripts is not getting the start and update getting called because I've disabled it. I re-enable it, the update gets called again. Now you see the counter happening again, right? But notice that start and awake never have two next to it. They were only called once. So start will get called when the object is enabled. Awake will get called when the object is created. If the object is created and it is enabled by default, then you'll see awake and start getting called next to each other. But you can understand the difference when it will get called versus when it will not get called. Okay, cool. So late update is very similar to update. It gets called at a certain frequency, but it is primarily used for physics. So when you want to detect, like if you're playing like a FPS, right, a shooter game or something like that, and you shoot a bullet, right, that bullet is a game object. It has some components on it that lets it detect when it hit something, say like an enemy or a wall or something like that, right? So that logic basically is inside late update. So anything that's related to physics is what's processed inside late update. Anything else that you need to happen every frame basically happens inside the update function. Okay. Don't worry about the late update part. We'll anyways, once we start talking more details about the physics and the collision and those kind of stuff, we'll come back to it. But this is something I just wanted to introduce so that you know that these are the predefined functions that come with Unity. You can Google for it, you can look up Unity's documentation, and you can find out what all other functions are currently used as well. The list is huge, probably like 30, 40, 50 functions or something. So you don't need to worry about knowing all of them. Most of the time, if you're using some kind of a, like IDE, especially Visual Studio, you can actually start typing and it will show you, okay, in this case, I have awake. So there's something like a fixed update function as well. So you can actually have that fixed update. It's not showing up, so something's weird with. But the idea is that you can always Google for it at that particular moment when you need something, but you should be familiar with what functions are. You don't need to remember all of them by heart. And as in you go with implementing these things you'll naturally become, embedded in your memory, that you don't need to remember what start is, what awake is. You automatically know these. Just things that come with practice. Let me look at the chat quickly. What? Sorry, Akash. Akash, I'm not sure what you mean. Akash, sorry, this is like your last warning. If I see any more sort of slang language, I'm gonna kick you out, all right? Cool. Surya, your question is, what if my scene got refreshed? Refreshed as in, I'm not sure. There is something called as reload. I'm thinking that's what you have in mind. But the point is basically if you reload your entire scene, it's as good as saying that I'm destroying my entire scene and creating it again. In that case, new objects are getting created, and obviously the same logic will apply. Because you've created a new object, your awake will get called again. If the object is, if this component is enabled, uh, automatically, your start will also get called, and then your update or fixed update, late update, all of these functions will get called as well. Okay, so whatever happens when an object gets created, that same sequence of things will happen again, because when you're reloading a scene internally, what Unity does is it destroys all the objects of that scene, destroys the entire scene, and recreates everything again. Okay, yeah, so everything will be called all over again. Cool. So okay, let me see what's next on the list. So we just basically covered these things. So on destroy is another Unity function that I didn't touch on. So something like you will have on destroy. As you can see, this is also a Unity specific function, which when I'm destroying a game object, Unity will call this function. So in case I need to clean up something. So if I have in my particular script, let's say if I have a an array that I created, right? An integer array for managing some, say, IDs, right? I have this array and I have this big list. So when this object is getting destroyed, I want to make sure that I'm deleting all these arrays so that there's no memory leaks or kind of thing happening. So on destroy gets called just before the object, just before Unity is about to destroy that object. Okay, so you can, if you've allocated some memory to data structures, etc., you can clean those data structures. You can make sure you mark them as null so that your memory is not getting wasted, things like that. Okay, cool. So these are some of the objects. We briefly talked about what enabling these objects and disabling these objects are. One thing I didn't discuss, or rather show, is, so we talked about enabling and disabling individual components, but what if I disable the entire game object? Now, in this case, my component is enabled, but my game object is disabled. So let's see what happens. In this particular case, you'll see nothing happen, right? Like no awake, no start, nothing. Why? Because my entire game object itself is disabled at this point, right? So if I have something like this, even though the game object exists, but the object itself is disabled. So Unity is not communicating with this object at all. So awake didn't get called, start will naturally not get called. So now I enable this object. You'll see an awake call, right? Why? Because now Unity knows that this object exists in the game and on which there is this component that it created, right? Even though this component is disabled, the component which we created, my first script, even though this is disabled by itself, but still the awake got called, because awake gets called, remember, when every time the object gets created. And then again, the regular flow happens. When I press this, naturally update and start getting called. And if I destroy, I don't have the log message in destroy, but if I actually deleted this object right now, you would have seen a destroy message show up as well, if we had a log message in the destroy. So these are some of the internal functions. Every time you're creating a new mono behavior, these are the most common functions that you'll access. And this is where the real power of Unity shines, because it's managing a lot of these things. By default, it gives you access to a lot of this functionality that you don't need to worry about. It just works straight away. And that way, you can focus on writing your own game logic and not having to worry about calling certain functions at a certain frequency, etc. Nowadays, pretty much every unit engine does this, but this is how we do it inside a Unity setup. Cool. So far, if anybody has questions, just let me know. I'll explain something real quick. Let me stop the screen share. All right, cool. So basically what happens is there is a very important concept of something called as a game loop. All right. So what is this game loop? So every time we have a game running in, it doesn't matter which engine we use to be used for actually building a game, right? Even if you're using some other engine, the concept of a core game loop remains the same. Now, what this thing tells us that there is a certain thing of, there's a certain sequence of things that will keep happening every time or every frame, essentially. And this was what basically kind of determines your frame rate. Okay. So when we say that our game is running at 30 frames per second, that means this sequence of events is happening 30 times each second. If I'm running at 60 frames per second, then it's happening 60 times, right? So this is essentially what a core game loop is. Now you'll be like, okay, so what are these events that are we talking about, right? So these events typically are things like checking for, say, collisions, right? So typically your collisions that get detected are detected in this loop. Your UI that needs to be refreshed is happening here. If things are animating, they're happening in this particular loop. So all these things are happening every frame multiple times, depending on what your frame rate is, right? And this is where Unity also calls the update functions that we just saw, right? All the update has like three different variants: the regular update, the fixed update, and the late update, right? So, but when I say update, I mean all the three, a category of update functions. So all of them happen at exactly the same time, right? So every frame, Unity will process all of these events, or if there is any other game engine, it will process all of these events, and that's how your entire sort of game runs. So if my bullet is, if I shot a bullet, it's here, next frame it's here, next frame it's here, next frame it's here, and then it hits, right? It took this steps. How did it take these steps? Because Unity is processing that I fired a bullet with a certain speed. Based on that speed, if in my previous frame and in my current frame I've moved, say, half a second, right? Then based on my speed and my previous position, in half a second I'll be here, in next half I'll be here, in next half I'll be here, right? So that's how it calculates. So everything around it is called the core game loop. Okay. So this is where it knows and processes all the things behind the scene, and one part of the core game loop is calling all the update and the fixed update functions. You'll see there are other functions such as like collision detection functions, etc. Those also get called as part of this particular game loop, but they only get called when a collision gets detected. Update and late update and fixed update gets called every frame, but certain other functions get called only when they are needed. When the physics system inside Unity says, oh, the bullet collided with, say, another player, right? Then it will call the collision functions on that particular thing. So behind the scenes, it's processing everything every frame, but it's calling the right functions at the right time when it needs to. Okay. Cool. So this is typically what happens, but this normally doesn't happen when you're building, say, a normal app, right? A normal app doesn't work like this. A normal app doesn't have like a physics collision detection logic. So it doesn't need to do a lot of these things. And that's why when we're building games, we need to be a little bit more uh, aware of that. Hey, we are not building things that take too much CPU, right? Because then we'll see our game starting to lag. So that's why we have to be extra careful in how we are building things when it comes to games, and not when we are talking about building, say, an Android app. There we can be a little bit more generous when we are, say, allocating memory and doing things like that. But in games you have to be very strict, because any kind of slowness in our frame rate, etc., can lead to a very bad user experience, right? Cool. So hopefully that's clear. That's one of the core concepts that people sort of miss. Let me quickly look at the chat. So game like stick football is also an example of a game. So every game, it doesn't matter what game, behind the scenes, Unity or any other game engine is running this game loop no matter what. Because when even if you don't have any physics or anything like that, still you need to redraw entire screen, because if you're moving a character or moving a ball or moving anything around, right, it needs to redraw that screen to update and refresh it. So everything kind of is a game loop, no matter what. All right, cool. What is my screen? Everything there? Yeah, all right. So let me go back to my screen share. All right, so that's basically the core concept of a game loop. Now we'll look into something about how to, we can do uh, basic things around, reading input, etc., etc., and how we can detect input. That's the most common thing that we have to do in any game, right? Even when we restart the game, Aryan, I'm not sure exactly what you mean. Right. So, I mean, if you're talking in context of a game loop itself, yeah, game loop is running anytime your game is running. So even if you restart the entire game, it doesn't matter. If the game is running, then the game loop is running. Right. Hopefully that clarifies your question. If it was something else, just leave a note in the chat and I'll come back to it. All right, cool. So we'll look at how to next detect some basic input, be it first we'll look at keyboard, then we'll look at mouse as well. All right. Does game loop even run when we close the game? No. So game loop is basically, like I said, right? Like when your game is running, that's when the loop is. When your app, whichever your app is, so if you build it as an Android app, right? Whenever that app is running and taking up screen, that's when the game loop is running. If you minimize it and move to some other app or something like that, then basically you have stopped the entire app, and that's when the game loop will also stop, because it's part of that entire process itself, so it will stop naturally. But if you if you maximize it and come back to it, then the game loop starts all over again, right? Cool. Let's switch back. All right. So now when we want to do something with, let me remove some of this code that we don't need anymore. So now the most common thing that any script that we build is, something that reads, first detects user input, and then does something on top of it. Okay. So the most common scenario is that you want to detect certain input. So if you're building something for the desktop, or like Steam, Steam game or something, you might be working with, say, a keyboard or a mouse. But if you're building something with mobile, then you might be using the touch screen as well, right? So there are different ways on how you can read input from a particular, from a particular device, be it a keyboard, be it a mouse, be it a touchpad or anything like that. So the most standard way, so we'll start with basically a keyboard as the simplest scenario. So what you want to do is you want to do something inside the update function, because I don't know when my player is gonna interact with my game, right? So I want to make sure that every frame I'm detecting if somebody has pressed a button. Say, okay, so in this case, let's imagine that I want to detect pressing, say, T, or any key for that matter. But for example, I'm going to go with T. So Unity comes with a standard way of detecting input. So there is a class called input. So you can see the first class that shows up is input. Input dot get. So here you can see that there are these different functions within the input class itself. Some of them here you can see is mouse button related. Some of them are touch related, and others are like key related. So key related functions correspond to anything on the keyboard, mouse obviously mouse, but there are different variants within each, right? So if you say get key, you can see there are three different versions of it: get key up, get key down, right? So what these individually mean is there are three specific stages when a user presses a button, right? So if I have a button, The moment I press it, it basically is a down function. Basically, the get key down function will get called in the very first frame that I press a button. As long as I'm keeping it pressed, if I keep it pressed for 5 seconds, for all the 5 seconds, Unity will call the get key function. Okay. And the frame in which I lift my finger and release the button, in that frame, it will call the get key up function, right? So that's the core philosophy between down and then the regular function and then the up function. Okay. So this lets you control when you want to do certain things. So the standard is either use up or down, right? Because up gets called once, down gets called once, but the regular get key function will get called multiple times. So if you want to detect it only once, so if I have imagine like a fire button, right? I want to fire say a gun or a bullet when I press the button, but I don't want to keep firing. It's not a rapid fire kind of a thing. Then I don't want to keep firing every frame the button is pressed. When I press a button, I might hold on for 1 second. That 1 second might mean 60 times, right? So I only want to fire one bullet when the user presses it once and then releases it and then presses it again, right? So I'm going to either fire when I put, in this case, fire normally means when you'll do down, but in other games you might want to do when I do up. So it's based on game design what function you want to use, but more or less you want to use either up or down in most scenarios, but there might be very few cases where you want to do detect it every frame. So something like, if you want to charge a super ability and you want to keep the button pressed for 2 seconds to charge up that ability, then you will see the get key function and keep counting that has 2 seconds passed since the user has pressed this button. If he removes it before the 2 seconds are over, then you reset the charge ability or something like that, right? So those are typically the kind of cases where you want to use these different functions. And when you look at the mouse ones, you will find same three kind of pattern of functions: the regular function, the up function, the down function for detecting mouse buttons. Right? So we're going to use the down one, just an example. So input.get key down. Now this function, when I see by default takes a key code. A key code is nothing but a Unity defined enum, and we're going to directly use this key code. When I say dot, here you can see a full list of all the different sort of keys that are available on a standard, keyboard. So I need to detect F. So when I press F, something like a fire, I'm gonna do something with it. Okay. So now I want to see, I want to detect this particular when the user presses the F button, and I want to do something on it. So I'm going to put it inside an if statement. If input.get key down, key code is F, that means I pressed the F button in the very first frame. I'm going to put a simple debug log to see what happens, right? So I'm going to say update input F pressed, and that's it. Okay, and I'm going to quickly just copy this so you guys can see. If get key up and F, and then I'm going to say input F released. Okay, so I'm going to say pressed when I'm pressing it in the frame I'm pressing it. I'm going to say release when in the frame I'm releasing it, and I'm going to similarly do the last one, which is get key, and we'll see how each of them kind of work. I'm just going to call this update input F. All right. So we have these three different things. Now we know Unity will call the update function every frame, right? So we'll see quickly this in action. All right. So I come back to Unity, let it recompile my entire code. Everything works fine, no errors. So now my game is running. So make sure you click on the game window, because your game window, if it's not in focus, it will pause the game. If I click somewhere outside, my game is essentially paused and it will not detect. So I click inside my game window and then I press F. What's happening? Did it not detect? 1 second. Let's debug what's happening. So I have input.key, key code is F, input.get key. Everything looks good. Then, oh, because my game object is disabled. That's why. All right, so now if I press F, you see, I just pressed F and released it. So I got one F pressed down event, one released event, but even for that fraction, I got 6 frames that detected the get key, right? So you see every frame, it's calling that function the moment I have the button pressed, right? So I'm going to do it again, and this time I'm going to keep holding it. So you'll see the initial function come in, then the update function come in. So now I have the button pressed, and now I'm going to release it, and you see the release message come in. Okay, so it keeps calling that update function, but now because I don't have the F button pressed, it's not going inside that if statement, right? So exactly the same thing you can do by changing the input, changing the different function on the input class. In this case, we can call get mouse, and here you see you have the same 3 pattern of functions: get mouse up, get mouse down, and get mouse. So let's try one. In this case, so the standard convention is that the left click is 0, right click is 1. That's exactly that. So if I do this, and if I replace my if condition with this, right? So this will basically detect my left click on the mouse, and passing 1 is basically my right click. So that's literally, like, this is the only thing that you need to change if you want to switch from a keyboard to a mouse. And if you want to support both, let's say, in that case, what you can do is you can do an or condition and actually have both of them together, right? Now, in this case, I want to say I want to run some logic either when I press F or I click left on the mouse. In this case, this if condition will evaluate to true in both the ways, right? So you can do things like that, that you can support both keyboard and mouse at the same time as well, right? Hopefully this is making sense. If anybody has any questions, just please drop them in the chat as well, right? Cool. So now we've looked at simply detecting how to, how to detect certain key presses either on the keyboard or on the mouse. And now we'll move on to something. Okay, so in this case, I was using spacebar, but I showed you with basically the different key, right? Same with the get mouse button. So now we'll look a little bit more into the Unity, how we can create a simple UI, right? So far we created a custom component. Now we'll look at some of the Unity's inbuilt components specifically around the UI. So for this particular scenario, I'm just going to delete my game object. I don't need it anymore for now. I'm going to even delete this camera. I don't even need the camera. So now, as you see, my entire scene is empty. I'm going to right click under UI. I'm going to create something called as a canvas. Now, if you see this, when I click canvas, it created 2 different game objects for me. So we'll briefly cover what these are. So canvas is basically the parent object of anything UI related in Unity. Okay, so anytime I'm working with UI, the highest level object for that particular UI will be the canvas object. Okay, so if in case I didn't have this canvas object and I wanted, hey UI, create me a text, I want to display like high score or something. When I click this, it will create a text, but it will say, oh, it doesn't detect a canvas in the game, in the particular scene. It will create a canvas and then create a text under it. So you see, it created a canvas because the canvas was not existing, and then it added a text as a child of that particular thing. So here you can see there is this new text that you see. It's slightly faint, but hopefully you guys can see it. So it created this text object. I can change this text to be anything here in my inspector view, right? So let's just delete this for now. But the point is that anytime you have a UI in your game, the parent object of all the UI would always be this canvas object. And this event system is something that comes with Unity's canvas system to allow you to detect all the button clicks, and whenever you touch anything on the UI, this event system is for that. So anytime you're detecting any kind of a click kind of a thing, whenever you're interacting with the UI, this event system detects those clicks and passes on to the right button slash right part of the screen that you're trying to click. Okay, so this is something that it creates by default. Don't worry about all the complex parts that seems like these different components that it has created by default on it. Once you start becoming more comfortable over time, you'll get used to what these are. So for now, if I'm going to minimize all of these, so again, you see on the canvas there are these bunch of different components, right? Now here you should see something interesting. This is not like we talked that hey, every game object comes with a transform, right? That's what we said. But if you look at this, this has something different. It has a rect transform. So since you're working with UI is all 2D. It doesn't matter, right? Whether you're making a 3D game, 4D game, AR game, VR game, your UI is always, your user interface is always 2D. So Unity has something called as a rect transform, which rect just means a rectangle, right? So a rect transform is for anything that's UI related. So it doesn't have the depth of the z-axis. It only has the x and the y, right? I only need a 2D version of something, and I don't need its depth. So Unity created a special component from the transform component called the rect transform, which does the things exactly like a transform, where it stores its position. So you can see position x, position y, but it has a position z, but it's always zero, because like I said, right, it doesn't have a depth. It only has an x and a y, and has everything else exactly the same. It has a rotation component, it has a scale, but it has certain extra things. We'll just touch on this, what this pivot and anchor and extra things are. But this just lets us sort of quickly position our objects with respect to how my screen will look like. Okay, so this is the parent object called the canvas. Now, when I look at the canvas component, it comes with these different things. Most of the time, you'll use canvas overlay. So for now, let's use canvas overlay. What this means is, whatever is my game, my UI will come always on top of everything. So if I have an object moving around and I have a button, then my button will always be on top. It's not like my button is behind and my player is front of me, so my player obstructs the button, right? So whatever game you have, if you think about like the settings button at the corner, or any of these buttons, your buttons are always on top, right? So that's why we'll use the overlay functionality for now, which just means that whatever my game is, my canvas is always on top of everything else. Don't go into rest of the details. These are things that we'll cover in future classes. So this is the only setting that you need to know. Most of the time, whenever you create a canvas, if you haven't changed anything, this is the default that comes with, because this is the most common one that everybody uses. There are other places where you'll use these two, and we'll talk about them later as well. Cool. So now I've created this canvas. Now, if I click, so these top buttons that you see, right? These kind of give you custom sort of buttons to play around. So this one is like a rotate tool that lets me sort of rotate things fast and quick. This one is like a scaling tool. If I want to increase the size of something, I can scale this by clicking and dragging. You can do the same thing by changing the numbers here, but this is just a visual way of doing it. So this is like a position tool. I can move the things around. Here you don't see anything moving because we're doing the canvas. Canvas is always fixed. It never moves. So that's why even these values are grayed out. You can't move them manually, but you can move all the objects under it. Okay, so these are like the different tools that Unity gives, and the hand tool is like the default when you want to move your entire scene things around. So this is the one that we default use. So what I'm going to do is I'm going to create a simple first an image. So I'm going to go to UI. I'm going to say image. So you see this sort of white box kind of appear right in the center of the screen. Now let's look at what this is. So my image by default comes with a few things. There's a rect transform, exactly how we just talked about. It's kind of a transform, but for the 2D world. So it has a rect transform instead of the regular transform. Here now you can actually change this. So if I want this image to be 200 by 200, now you see it's bigger because I just put in these new width and height. Scale is the same thing. I can say the scale is twice. So now I put in 2 for X. Now it's basically stretched the entire image to twice the size. So you can see there is a separate component called image. And you can see the script tag next to it, right? Which means Unity has written a script by the name image. Very much like how we created our script, this is also a script, right? Just that Unity has created it for us. So we don't need to create these basic things. So I'm gonna click on this button called source image. Right now it's showing just a blank white color. I can change the color by clicking on the color thing. It'll just pop up this tool that lets me change these color values. Very similar to how you can even do things in like Photoshop and such. So I picked this random ugly looking color. So right now there is no image that is showing. So it's just filling the entire area for this particular image with the color that I've selected. Because if you see source image, it says none. There is no image associated with this particular, there's no actual image to be displayed. So what I'm going to do is I'm going to click on this button next to source image, and Unity will show me this sort of some predefined images, the default one that comes with it. So I'm going to select a knob. Now you see this kind of green image show up. I'm going to just reset the color to be white again so you can see clearly. Now in this case, remember, I had scaled the X value to 2. So you see this sort of knob image getting stretched. So I'm going to do it 1, and now it actually has, it looks blurry. That's because it's huge. It's not supposed to be that huge. But the idea is that now the aspect ratio of this image is correct. If I increased it, you'll see it getting stretched, but I want to keep it 1 for now. So now this image looks consistent. The same thing I can do if I reduce this, it will still look stretched because I'm not keeping the aspect ratio consistent of this particular image. So now this is like 100 by 100, much smaller, and I can just use it out of the gate. I don't need to import any other extra art assets or anything like that. But of course, I can drag and drop some extra images and replace this particular thing with it. So imagine if I had an image downloaded, I would have dropped into this folder. What you can do is you can drag it from here and just drop it here, and it will replace. Or if you are not able to do that, then you can obviously click here, and it will show all the assets that can be applied to this particular image. Okay. So now this is like a basic image. Now what we'll do is we can quickly select this option, and now I can move this image around. So what you see as the boundary, this white box of the canvas, right? So if I select the canvas, so you see these 4 corners, right? This is essentially my entire screen. Okay, if I build this for Android and actually run it on an Android game, this is what exactly I'll see. So if I have my image at 0,0 on X and Y, that means I'll see this image at exactly the center of the screen. Okay, but I want to show this image at the top corner. So I'm gonna position it something like this, right? So if I come in the game world, game view, you'll see now it's at the top corner. So I'm gonna quickly get this game view here. So when I make some change, you can actually see it in action at the same time. So now you'll see what happened is that since I changed the size of the screen, my object has gone off. So this is the kind of issues that you usually come when you're working with like different screens and whatnot. So what I want is my button to always be in the corner irrespective of what my size is, right? So right now, if you see, I'm reducing the size of the screen, and my image is going outside the screen, right? So what I want Unity to do is, instead of having this position as fixed, because right now if you see in the inspector here, right, these numbers will never change because I manually positioned them at some location like this, right? If I keep reducing if you see in the inspector view, the position for X and Y is never changing, right? That's why on a smaller screen, this will not be visible. If my screen was this small for some Android device, this would not be visible in the game. But we obviously don't want that. So that's where these anchors and pivots come in. And these are only for 2D UI. These are not for 3D objects. 3D objects work slightly differently, okay? So what we will do is we'll select this image. When you click on this kind of this icon, right, you see this bunch of stuff show up. So what this is saying is, I want to position my object with respect to my parent object in a certain way so it always maintains that. So if I have, so there's something called as a pivot and an anchor. Pivot is usually the center point of my image. So in this case, if you see, if I have my image selected and I switch here, switch to this box one, right? So you see this center dot, that's where my pivot is. And these four are my corners, right? So you can probably see this now. So the center dot is my pivot. And here you can see 0.5 and 0.5. So irrespective of what this size is, pivots are always calculated along the x-axis and along the y-axis. The one corner is 0, 0, the other one is 1, 1, and same with 0, 0 and 1, 1. So when I say 0.5 on x and 0.5 on y, it means the center of the image, irrespective of what the size is. Okay. So if I want to say pivot 0 and pivot 0, now my pivot is at 0, 0, but it's not at the center of the screen anymore. Okay. So most of the time, you don't need to change these values by hand. What you need to do is you want to click on this particular thing and it gives you this predefined configuration, right? So you can see this one says pivoted to the top left corner, pivoted to the top right corner, and things like that, right? Pivoted to the center of the right, much like how you would sort of align, say, a text in a Word document, right? So these are kind of predefined conditions that come with it. Okay. So what you can do is, most commonly on Mac, it's basically Shift and Alt. I think on Windows, it's Control and Shift. But Unity will show it to you here. So what you want to do is you want to select. So I have the two options pressed, right? Right now I have basically Control, Command, and Shift, all of these three options pressed, and I'm going to click something like this. So you see this kind of new thing show up, because what it's doing is it's pivoting this particular image to the top left. Don't worry if a lot of this stuff doesn't make sense immediately. You can go and revise this particular section and actually start playing with Unity itself, and you'll get a hang of it better. It's slightly something that you need to get a more comfortable sort of getting a hang of things. And here also you can see it is showing the top left now. So now if you see, even though I'm reducing the size of the image, it's always with respect to that top left. It never goes off screen, right? So what I've done is I've said Unity always anchor this object with respect to the top left corner of the screen, no matter the size, right? So now I can keep changing its size. The image is still always visible. There are other problems, because now the small image is taking up half of the size, but the core concept is that when we are working with these, different aspect ratios and different resolutions, this is typically how we work. So you want to make sure that you're setting up the right anchors and the right, right pivots. And most of the time, you don't need to manually change these values, because now you see these values have gone different now. Now everything is different, because this is 0, 1, 0, 1 kind of thing. I can do the same thing, and I can anchor it to the bottom right corner of the screen, right? So I don't need to, in this case, if I zoom out, now you'll see the actual sort of thing is now reflected here in the bottom right corner. So now it will be anchored with respect to the bottom right. But in this case, it will go out because it's too far away from the bottom right, right? So if I want to do that, I want to make my object move closer to my bottom right corner on which it is anchored, and now it will always be visible. Okay. Hopefully, it's making a little bit of sense. again, you'll get more comfortable once you sort of play around with these, because this feel like there are too many options, right? So don't worry about that. You can play around with it and kind of get a more better hang for it, right? Cool. So this is something very sort of straightforward that you want to do. I just changed the settings. So now it is basically stretched vertically. Most of the time, we don't want to do that. We always want to keep it like this. But certain cases, we want to make sure that if it's filling the entire right bar, like if you want to show it as a strip, right, then you might use that option. So yeah. Cool. Any questions so far? Just drop them in the chat. Let me look at what. Okay, so we looked at the basics of this. So we looked at images. Other things which are very similar to images are text and button. So what I'm going to do is I'm going to quickly go and say UI text. It's going to give me a text, say hello world, and I'm going to change the color just so that it stands out on the background. So now let me just disable this setting. Yeah. So now you see basically this hello world. So there is this, since we don't have a camera, Unity says, oh, maybe you're doing something wrong, you don't have a camera. You can just go to the game view, warn if no camera rendering, you can disable this thing so it doesn't, block your view. We can see it clearly. So now we have this text. Again, it's nothing but a simple text component. So if you look at the image, and let me minimize this. And so if you compare the two, right, they're nothing but two simple game objects. Each has a rect transform, and each has a canvas renderer, which just means that it's under some canvas. So it's something that's internally Unity needs. And then after that, you see the image game object has an image component, the text game object has a text component. It's as simple as that. What you can even do is you can, so now we'll create say a button, right? So I'm going to go to UI and create a button. Now this button is a complex game object. So it is itself a game object, and it has a game object under it as well, right? Because buttons usually come with some information like what this button is, or what does it do. So say something like play, right? Or start the game or something, whatever, right? So play. Now, this is an example of a complex game object. So I'm going to just move it up slightly, just so I can show clearly. So if you look at this button, it comes with both an image and an individual component called button. So if I disable this image, you'll see the entire thing go away, right? But you can still see the play text. Let me change the color so you can see it. So you can still see the play text because it's a separate game object under it. Okay. So I'm going to enable it. That's where the actual button is now. So this is too light apparently. Yeah. Cool. So now hopefully things are starting to make sense, right? These are all individual components that can be individually controlled. If I disable this image, you don't see that white box that button comes with, but the button will still work because it's there. The button itself is there. It's just that we've disabled the image for it. And I can go in and disable the text, and naturally you'll not see the play thing written there because obviously the game object for it is disabled. All right. So that's the core idea behind a couple of these most basic sort of components that you'll most likely create in every game, no matter what, right? So that's that. Now, remember we talked about scenes in the very beginning, right? So we've created this as a sample scene. So whatever we have created right now here is nothing but a simple scene, right? So I can actually rename this scene. So you can right click and say rename, or just click on it again and it will give you this. So I'm going to call it first scene. Okay, I'm going to create a new scene. So we create new scene, and I'm going to create second scene. So what I'll show you now is, So this is right now in first scene. If I switch to second scene, again, you see this is exactly how we started the project, right? An empty scene which just has one main camera and nothing else. We'll go ahead, even delete this one. We don't need it. And we're gonna just create a UI text, and this text will tell us that this is the second scene. Okay, so we'll just write second scene here and change the color so we can actually read it. Okay, so now we have this first scene and then we have this second scene. So there are two separate scenes, right? Now we'll look at the most basic interaction of how to, now we want something to happen when this button gets clicked. And now we'll see a little bit of code, back to code again, of how we can make this work. Okay, so I come back to my original script. I'm just going to get rid of this other things that I don't need. One second. So right now we don't need any of this. We'll just create a simple sort of thing which will let us create this button. So I'm going to create a public button. So now import Unity UI. So now I have this button class imported. Okay. So inside my start function, what I'm going to do is button. Now I want something to happen when this button is pressed. Okay, so let's first create a simple function, private void on button click. Okay, so what do I want to happen? I want something in this particular function to get called when this button gets pressed. All right, so what I'll do is I'll say button dot on click. So Unity gives us this default event, and I'm going to say add listener and on button click. So this is a standard format that we use. So what this is saying is, for this particular button, whenever the click happens, I want this specific function to get called. Add listener as in listen to this on click and call this function whenever this button is pressed. Okay. So here I'm just gonna do the most simple thing, and we're gonna say debug.log button clicked. So now we don't need to check for this button click inside every update. Why? Because Unity has a standard way of detecting all these clicks on every specific button. Because when you're doing that, you're wasting a lot of resources. Remember, you're running those if conditions of if input.get button, get key, etc. Right? You're running them every frame, but the user is only interacting for a short amount of time. So you're running that code unnecessary, and that's wasting your battery, right? So for the standard UI, Unity, every time there is a an interaction that's happening, there is most likely an event for it. So in this case, this on click is a button click event, and whenever this event is triggered, we want Unity to call this particular function, and that's how we have told Unity to do that. Okay, so I'll switch back quickly to code. Switch back quickly to this. Now I'm going to create my empty game object, attach my script on it. Now here, if you see, I created a public button, correct? So I said this is a public variable. Now if you see here, Unity has shown us that there is a public button, and we want a button object next to it. So I'm going to take this button, I'm going to keep this object selected, I'm going to click and drag this button into here. So now I know that my first script is listen to this button. Okay, so every time this button gets pressed, the respective function in my first script will get called. Okay, so let me disable this text and image so it's clear. Now I'm going to hit play, and when basically we press this play button, you see this log message show up. Click on this button, you'll see multiple times this counter go up, right? And when we double click in this console, it comes back to the code and shows us where we had actually clicked it, right? So So this is the most simplest way how we'll detect events inside UI. Okay. So now the most basic use case that we want to do today is, and this is the last piece is, remember we created these two scenes, right? So what we want to do is we want to start the game in first scene. Whenever we click the button, we want to transition into the second scene. Okay. So for that to happen, we'll go to something as build settings. So inside file, build settings, and here you see there is something called as scenes in the build. So this is something that you just select and add here, and that's it. You don't need to do anything more than that. All this does is that it lets Unity know that these are the scenes that we want to work with. These are the active scenes that we are using, so we want to use these scenes. So before you can change scenes on the fly dynamically through code, you need to make sure that all the scenes that you want to do are actually available here, right? So what we will do is we'll again come back here and we'll say public string second, or rather say new scene. Okay, so whenever we want to detect this click, we want this game to load this new scene. Okay, so what we will do is we'll use Unity's inbuilt functionality for scene. So there's something called as scene management. Okay, so let me import the namespace using scene management. Now there is one second, what is the exact? Let me put it here so it's easier and it shows in autocomplete using Unity engine dot scene management. Okay, so now what we want to do is, now we want to use the scene manager and we want to load a new scene whenever this button gets clicked. Okay, so I say scene manager. Now you see this load scene function. Okay, so this is what we're going to use. We're going to say load scene, and in this case we're going to pass it this new scene as a string. So we have defined this new string and we're going to pass this here, and this will let us whatever we define here in the inspector will get passed here, and the scene manager will load that scene for us. Okay, so if I come back, I look at this button, I look at this game object which has my script attached. Now you see a new variable called new scene. Now what I want to do is I want to specify the exact string. So in this case it is second scene. All right, so second scene is the name of the scene, and this is what I've specified here. So if I hit play and when I press this button, what it will basically load a scene which has the name matching to second scene. So in case I made a typo here, it will show me an error. If I type this string correctly, then it will jump to that particular scene. So if I click play, it loaded the second scene, right? So here you can see that there is a second scene which has this text called second scene, and that's what you see on the screen. Okay, so that's the second scene. So if I stop, again Unity defaults back to how my project started, which is basically the first scene. So that's how sort of scene transitions work in Unity. Your entire game would be broken down into different scenes. So imagine like if you have 100 levels in your game, right? Each level will be most likely a new scene. And when the user click, I want to play level 14, you'll say load scene for 14, and that way the scene 14 will get loaded and the user will start seeing whatever is inside scene 14. Okay, probably some level for it, etc., etc. So these are the most common fundamental things when it comes to working with Unity, right? So I could have directly hard coded it here as well. So I could have done something like scene manager and passed it the second scene itself as a string here. But the only thing is then I cannot use the same script somewhere else. Because I've defined it as a variable, now it lets me reuse the script in multiple places, and I can change it in the inspector. Okay, cool. So hopefully that's clear. Any questions so far? That's pretty much the. If you have any questions, just leave them in the chat quickly, and we'll address them. But that's pretty much all we wanted to cover today. So we covered the basics of what each of individual these components are, how we structure them, a simple look at some of the basics of Unity's UI system, and how to create some simple things in different simple scenes. Now, your assignment for this particular week is all listed here. So we've covered all the UI, canvas, anchors, button clicks, scenes, and loading a new scene, right? So now your assignment for this particular week is, so you'll create a new project and push it on Git as a first, your first project. And then after that, you'll create 4 scenes. One would be your master scene, and 3 scenes would be basically just highlighting like how I had second scene. You'll create 3 scenes that say scene 1, scene 2, scene 3, and the master scene says master. Now you'll create 3 buttons. Each of these buttons will take you to the next scene. Okay, so very similar to how we did, but you'll have 3 of them. Okay, so you'll have to create multiple game objects with multiple buttons and link them to multiple things. So when I click on button 1, it should load scene 1, and I should see the text. If when I click button 2, it should load scene 2, and something similar for scene 3, right? The added thing is that what we want to do is that once I am in scene 1, 2, or 3, this is sort of a bonus challenge for you to figure out that what you want to do is you want to navigate. There should be a back button in all of these scenes 1, 2, 3. When I click that back button, it should go back to the master scene. Okay, so this is something that you will have to do a little bit of Google and figure out. Join our Discord basically, and if you have any questions, we have a lot of game developers there active, that you can ask as well. So, but this is the core assignment for this particular week. So if you're having issues or anything like that, just feel free to ping on Discord or reach out to us. All right, cool. Any other questions? Surya. Okay, Surya, can you leave your email ID / contact information in the chat, and I'll get back to you. Um, cool. So that's core essentially what we are. So this is like the first technical session on game development, especially with Unity, and going forward, we'll keep going deeper and deeper into each of the topics. So next week, we'll start working on a proper 2D project. So we'll provide you with certain setup for a 2D project and start building a game up. So we have an advanced level class as well, which I think most of you might already be familiar with. And that's the class where we'll actually start building a lot of these projects up using the same fundamentals that we just used. Okay. So things will start getting more complex pretty soon. So cool. So I think that's pretty much it for today. Thanks everyone who showed up and even stayed till the end. Appreciate that. If you guys are interested, so people who haven't signed up yet for the full course, just reach out to us through your channels, whoever you got in touch with for signing up for the course. We'll start working more on getting everybody set up with GitHub / specific projects and details like that, and start building both 2D and 3D projects. All right, cool. So it looks like there are no specific questions, so we'll wrap up for today. Yeah, so we have our YouTube channel and Discord. Let me just paste the links as well. Can you please that? All right, cool. So Vishal will just paste the links for both the YouTube and our Discord channel, so you can join those. Actually, if you just go to www.outscal.com, you'll directly get our Discord link there itself. Discord, LinkedIn, all the relevant information you can directly get there as well. So that's predominantly that's our website, outscal.com. That's the intro link, Vishal. The one that you shared, right? That's the intro course link. But yeah, I mean, if you haven't signed up on that particular thing, just please do. Uh, but I can share you the exact link for Discord as well. It'll probably be bit.ly. Let me look it up. Slash. Yeah, this one, right. Cool. So just yeah, join this Discord channel as well, and then you can just directly post any comments, etc. that you might have there. All right. And I'm available on Discord pretty much the entire day. So if you have any specific question, you can also ping me there as well. Cool. All right. Thanks, everyone. We'll put up this video later tonight on Discord as well. Oh, sorry, on YouTube as well. So it will be available for rewatching in case you want to revise. And if you want to enroll, then just follow up with Vishal or whoever you might have communicated with who told you about this session today. And yeah, we'll get you set up with the account and all the right software and etc. that you need for continuing forward with this course. All right. Cool. Awesome. All right. Have a fun weekend, everyone. I'll hopefully see you guys in our Discord channel and we'll continue from there. All right. Take care. Bye.